And now with the more circles being placed, and now those are the first step, and you have to label those things correctly. Then we can go to the step 3. The step 3 is, let me write out here. Step 3 is to use more circle. Information to identify, not to calculate, really is, okay, we can define the principal stress and the principal orientations and the maximum or the minimum stress and then the corresponding orientation for the extreme, the shear stress. Okay, so that is the step 3. And for this example, we can see on this graph, on this drawing, we can right away to identify where is the maximum and minimum the normal stress. For this example, you simply look at the graph. Where is the maximum normal stress? What is the value? Here, right?
No.
The maximum value of the normal stress, right? So that means here you measure the distance. Here is our maximum, right? And how much? Is 7 plus R, 12. So basically that is our formula. So you don't have to memorize the formula. You don't need to use the formula, but you can simply look up your drawing and you can get the answer quickly. And the minimum happens at here, and that is the distance, is the minimum. By reading this graph, you can quickly tell this is equal to 2. And the same thing, that is equal to, per our formula, is average minus R. Okay? And for this example, then this one here is 12. And for this value, that is sigma minimum is minus 12. Okay, and here, the distance here is 2, so the maximum is minus 2. Here I want to emphasize, here sometimes the symbols for minimum or maximum is totally confusing. So in terms of our design, I would say the maximum magnitude. In terms of magnitude, I would say here is the maximum. But anyhow, you know that in terms of our design, say for example, we always looking for the maximum value is less than or equal to the allowable stress, right? So that means in terms of this design, you should be able to use the 12 rather than 2 for this kind of design problem. Okay, so that is right now I fixed the 2. And now using the graph, I want to help you to determine theta p. And here again, I will take in the one more rule, and before I explain why. And here, because that's the rule, you just take it and don't ask why. Okay.
How often did we ask?
But I will explain that one very quickly. This one corresponding is the new orientations. For example, here is our maximum here. This is our minimum here. So, for example, in terms of our transformation, earlier what we did is this: we transform our block in this way by certain theta. And we, in our definition, sign convention is this is a positive theta, and this is a negative theta, right? And then, for example, if we rotate in this orientation, then in this new plane, this is sigma x prime, right, etc. And we can do the same thing on here. So, for example, here, if we would choose to rotate into these orientations like this, okay, so that means, say here, let me rotate and into here, and into this is the new orientation x prime, y prime. So that means turning into that orientation equivalent on the graph, look at here. maximum occur at this point, if we will be able to rotate the x point to here by rotating that much angle, this angle, let me call is called the 2 theta p. For whatever in this case we rotate by angle, equivalent on the Mohr circle is twice of that angle. Again, this is a rule. Take it. Okay? Take it. So here is, again, to calculate this one, this is theta p, on which in here we can see when x is rotating to this point, let me call it x prime. When y rotating in this orientation, basically here we rotating is we take this diameter as a stick and then we rotate to here. So this is our y prime. On x prime, that has a coordinate is sigma. For this example, this has a coordinate 12 and 0. Representing is here is 12. The 0 has no strain stress. On y prime, it has a coordinate from reading from the graph is 2, 0. So that means from here is 2. This is our first, the principal orientation. Okay, so to calculate these things, we can correctly label the either maximum or the minimum. If you remember last time Wednesday, we have to do kind of little bit kind of complicated calculation and verification to determine where is 12, where is 2, right? But graphically, we can do this very quickly. And now remaining is what is theta. So here is theta p, to theta p on here, so we can do the calculation. So for example, here is, say, let me utilize this triangle. Let me use this triangle here. So this is 90 degrees. Let me draw the triangle here. It's a 90 degrees, and theta p, this is a 2 theta p. And for this triangle, what is the distance here? Anyone can tell? How much is here from here? This is from center to 10, right? 3. And then what is the distance from here to here?
4.
Here, if we only focus on the magnitude, okay, so here in this way you can see tangent to theta p equal to 4/3. So therefore, theta p equal to 1/2 of arctangent 4/3, and anyone can help? And I think that is 53 degrees, right? 1/2 times 53 degrees.
Yes.
Okay, so that means theta p is equal to 26.5. And if you have your calculation with you from our formula last time, that should be this number. Okay, so that means here, per our calculation, the theta p equal to that number here. And then what is the orientation? Orientation is follow our chosen direction. We choose to go this direction. So that means here is counterclockwise. So that reason why here I know the answer, so here I do the counterclockwise direction. Turning, we rotate from given orientation by 26.5 degrees counterclockwise. Then this side will be 12, this side will be 2. That is the normal, that is the principal orientation, principal stresses. Okay? You might ask me, can we do the other route? Say we go here. Yes, we can do it. And let me do this one. So let me erase those informations. So if I do this route, so say let me call this is another 2 theta p. Say 2 theta p. If you wish, you can say this is 2 theta p1, this is 2 theta p2, 2 different angles. Okay, either way will do the work. So if we would choose this one, then if we would like to choose this way, then basically again we put this as diameter as a stick, then we rotate per our chosen direction go that way. So that means if we go this way, x will go to this point. So this point per our selection, this will be our new x. Let me call the x double prime. Okay, to distinguish, to make it to distinguish from this label. And again here, because I choose this clockwise direction, so we choose to here. So that means here the x will be moving. So x will be moving until to here. So x will go to the x double prime. So from here, the theta p2 is clockwise. So that means here when we draw it, clockwise, okay? And in that orientations, let me draw it in this way. So again, the x move to x double prime. So this is we rotate our x-axis into here. So this is our new x-axis, and here for our symbol, let me call this is x double prime, and this is our y double prime. Okay, that's just the symbol for the corner systems. Okay, so hopefully you can see what I mean. Okay. And then we can see when we rotate in this direction, x move to x double prime, and x double prime has the coordinate 2, 0. So in this orientation is 2. The normal stress is 2, right? And then y move to here. This is our y double prime. Y double prime has a coordinate 12, so this is 12. Okay. And so in this way, we can calculate 2 theta p2. And here you can see, because 2, you look at this one, the 2 angle, this angle plus this angle is equal to 180 degrees. So here we have calculated here earlier, this is 53. So here should be, this one should be 127 degrees. So this is our 2 theta p2. So therefore, theta p2 will be equal to how much? 63.5 degrees. So that means here 63.5 degrees.
What's the benefit of finding two, like the first one and the second one?
Let me fix this one first and answer your questions quickly. So that means here that should be 63.5 degrees. So let me do this one more time, sorry. And here should be 2, here should be 12. And here is our x coordinate, y double prime coordinate. The question is, what is the advantage of choosing either one? Right? And the answer is this. You can see here my drawing is not so perfect, but suppose the two angles must be 90 degrees. Okay. And under this orientation, if let me take away the artificially defined the corner systems, you can see this stress block actually is the same as this one. Got it? Yes.
I guess I'm a bit confused as to why the, at least when you had initially the y prime, between the two transformations, so initially the y prime was 2 and then the y double prime was 12. Why the two swapped, I guess you could say.
Again, here I take the different route. In the first choice, I choose this direction. I choose the counterclockwise direction, so that means x move to this one. So here, this stick move to here. Okay, so this is our x prime, transformed x direction. And in the second choice, I do the clockwise, so we transform to here. So this is our transformed x the direction. So that is the answer. For the answer, what is the advantage or disadvantage? Either choice will be fine. Either choice will give us the same result, because you can see the 12, the maximum normal stress is pointing in that direction. Again, my drawing is not so perfect, but this is supposed to be 90 degrees. If I would fix my drawing precisely, then you can tell this 12 is always in that orientation. So in terms of this board, the maximum normal stress should be in that orientation. The minimum normal stress is in this orientation. Okay. And so here, in terms of this given question, they should have two values of the principal rotation. One is theta p1, one is theta p2. So for this case, theta p1 is more precisely, you better to label it. This is a CCW, and this one is CW, because not only magnitude, but also the orientation, the direction matters. Don't worry, we can try one more time for this example, and let me redraw this one. How about that one? So let me redraw this one. So x is, this is here, this is here. The x is going that direction. Okay, let me take away the coordinate. So here is 4. So from here to here is 10. Okay, and with this one, again, we can choose either way. For example, say we take the acute angle. So if I would choose go this way, okay? So again, I choose to rotate in this way. So that is the counterclockwise. So corresponding to our real case, we rotate counterclockwise, so rotating in that direction. So here, let me put it into here. So that is the case, x and y. If you like, you can redraw just like me, just like I'm doing here. So that is 4. Okay. So again, right now, if I would choose go this rotation, so x will move to the transformed coordinate, the x, and this is our x prime, and y will transform to the y prime. So here is counterclockwise, so counterclockwise will go that direction. Okay, counterclockwise. So go to counterclockwise, then this is our transformed x coordinate, x-axis. This is our transformed y-axis. So now this is the transformed, the x-axis on which the coordinates here represent is the stress. So here the coordinate we can read from the Mohr circle is minus 12, 0. Minus 12, 0, this is the normal stress. This is the shear stress on the x prime. So this is minus 12. And 0 in shearing. Okay? And now we go to here. The y prime has the coordinate is how much? Minus 2 and 0. So in the y prime plane, we have the normal stress is 2 and 0 shear stress. So that is our first choice. And on the other side, you can go in this way. Okay, so if we would choose to go to clockwise, so then in this way the x will be transformed to here, y will be to here. So for this option, this will be our transformed x-axis. Let me label as x double prime. And y go these directions will go to here, so this is our transformed y-axis to here. Okay? I'm talking very quickly. I'm waiting for if you have any questions.
Does it matter how to get the theta p when you do your triangle? Does it matter if you take above or below the axis?
No, doesn't matter. Doesn't matter.
Okay.
Yeah. Okay. So now for this case, here is counterclockwise. So we go to counterclockwise here. So here, let me draw that one 90 degrees here. So now for this option here, we rotate clockwise. So here is